Whoa, 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 the recording is on. Yeah, yeah, yeah. Hi, everybody. Welcome, welcome, welcome. And let's get physics rich. I have a beautiful problem to share with you all about two of my favorite dear students, Mr. Soorya and Mr. Veera. And we are doing the Soorya Veera problem. Now, let me explain this problem to you in a short bit of detail. This problem is of two-dimensional kinematics, projectile motion, and what is happening here. There is a cylinder. As you can see, there is a cylinder, and Mr. Soorya is sitting on top of the cylinder. Now you see, guys, that Mr. Soorya, he's actually pretty brilliant at physics, but he also is brilliant at eating apples. He likes to eat. As you can see, sometimes Soorya can eat enough so that he has his own gravity. Okay, if Soorya is watching this, um, you know I'm right. So Soorya is eating the apple, and his dear friend, childhood friend, Mr. Veera, is sitting at the bottom of this floor. And Veera also wants to eat the apple. And Veera asks Soorya, "Dee, எனக்கு apple கொடுங்க." And after that, Soorya starts to think, while I have to give the apple, so why don't I throw the apple with the minimum possible speed so that it reaches Veera? Anyway, Soorya doesn't really like doing much things, including coming to class and studying physics. So he only likes to do two things: studying physics by himself and, well, eat apples. So he throws the apple at a minimum possible speed and it reaches Veera. Okay. And we have to find out that at what speed he must have thrown so that it reaches Veera without getting dirty. Why would the apple get dirty? If it would roll on the surface, it would get dirty. But Soorya must have done something with which it goes tangentially to this perimeter of the cylinder. All right. Now you see, guys, this problem is particularly difficult to solve if we solve it from Soorya's perspective. Because if we solve it from here, we're going to have to take, well, a horizontal component, a vertical component at this point, and another horizontal and vertical component at this point. Okay, fine, the horizontal components will be same because in a projectile motion, the horizontal components do not change. And yet again, there will be an angle from the center over here. So there are so many variables going on, it becomes very difficult to solve from Soorya's perspective. So we apply a little bit of hack over here. And what is that hack? The hack is that instead of making Soorya throw the apple to Veera, we make Veera throw the apple to Soorya. Okay? But the result is anyway going to be same because projectile motion follows some sort of a symmetry. Like if Soorya throws the apple at a certain velocity, at a certain speed, and it follows all the velocity points up until here. If Veera reverses it, it will follow the exact same trajectory and reach over here with the same speed at which Soorya must have thrown. That's the concept over here. So we are not going to solve the problem from Soorya's point of view. We will solve this from Veera's point of view. All right. So let's try to solve. So you see, I have written a bunch of equations over here, and I will try to explain to them why all these equations and why are they important and what are we going to do. So let's assume that the speed with which Veera has thrown this from the bottom is v1 vertically and u horizontally. Now this reaches over here and becomes, again, u is horizontal and v2 is vertical. So guys, what we do over here, we first try to analyze a few important things. That this speed, the speed of the apple at this point makes a certain angle with the vertical, okay? And that angle is alpha. This angle is alpha, okay? If this angle is alpha, I will leave it up to you as to why this angle will also be alpha. Please try to figure this out on your own. This angle is alpha, this angle will also be alpha. You can say that because this is alpha, u upon v2 must be equal to tan alpha, okay? u is the perpendicular and v2 is the base, and that's why their ratio is tan alpha. All right. This v0 is the speed with which Veera has thrown the apple now, okay? And that is equals to v1 square plus u square. What is v1? v1 is the vertical velocity and u is the horizontal velocity. All right. Are we clear with this and this, these two things? Now, the second very important thing is that we will try to analyze the apple's motion from this point to this point. At this point, it has a certain horizontal velocity, which is u, and it covers a distance of r cos alpha. And we write x equals to ut. So r cos alpha equals to ut, t becomes equals to r cos alpha by u. Now, what we do is that we see what is the value, how can we use this time value. So we see that for the motion between this point and this point, there is a vertical displacement. And that vertical displacement is r minus r sine alpha. And that r minus r sine alpha should be equal to uyt minus half gt square. And we put the value of uy, and the uy is nothing but v2, and v2 from here is u upon tan alpha. And we put u upon tan alpha over here, and the time as we have calculated over here, r cos alpha upon u. So we put that over there. And this r cos alpha upon u goes into the t square over here. And when you solve this, please take a moment, pause the video and try to do the maths of this. You will realize that u square comes out as gr by 2, 1 plus sine alpha, sine alpha. Pause the video, guys, and do a little bit of maths and take the u out. And I would like you to see that u square is coming out as this value. Okay. Now, the thing is that you must be wondering, sir, why are you after u? Why are you trying to find this? So my dear students, you know what I'm trying to do. My aim is to solve this problem in such a way that I am left with only two variables, because you see, I have a minimization problem. And whenever I have a minimization problem, I am supposed to express one variable in terms of another variable and do a little bit of calculus. Okay. So I have found out u in terms of alpha, and now I am looking for the V naught, which is the speed with which Veera has thrown it, in terms of alpha. And I'm going to say that V naught squared will be equal to V1 square plus U square. Now, this V2, you see what this V2 is? V2 is U upon tan alpha. Okay, we already have U from here, U upon tan alpha. In fact, we can also find out that there must be some speed with which this is going over here. Okay, and you can see that this direction is u, and this direction is the speed with which it is going. So if I do a cosec, you'll see on the next page, if I do a cosec, then I get the speed v dash with which the apple is going over here. So this is u, this is u, this is alpha, and this is u cosec alpha. Now I simply apply v square minus u square equals to 2s between this point and this point. Okay. So what do I do? Final velocity squared, v dash squared, minus initial v square equals to minus 2gr1 plus sine alpha. Now, why am I doing r into 1 plus sine alpha? Because this distance, you see this distance, this is r1 plus sine alpha. Okay, this angle is alpha actually. Okay, so there's a minus g over here because obviously the gravity is acting downwards. And then when you rearrange it, this comes out as you can see, I have done the calculation. V square comes out as this value. Okay, V square comes out as this value. Now, when you see V square as this value, which is what we are actually trying to find, okay, V square, I'm sorry, this V square is the same as this V naught. Okay, so let me just put V naught over. There's a V naught over here. This is a V naught. Okay, this is the speed with which Veera has thrown. All right. Now, you must be tempted to look at it and do some calculus. But I will do it without calculus, and I will show you how. You see, guys, that if we arrange this little bit, we will get a term of 1 upon 2 plus 2 plus 1 upon 2 sine alpha plus 2 sine alpha. All right. And now I want to tell you what happens when 1 upon 2 sine alpha and 2 sine alpha are put together. You see, this becomes a format of 1 upon x plus x. There is a 2 sine alpha and 1 upon 2 sine alpha. And the minimum value of this in the positive terms is always 2. Y is always 2 when x equals to 1. When x equals to 1, y is equals to 2. You can do this by doing a quick differentiation by 1 upon x differentiated is minus 1 upon x square. X differentiated is 1. If you put that equal to 0, x comes out to be equal to 1. We reject the minus 1 because we don't need it in physics. So this value simply becomes 2. I put that equal to 2, and this becomes 9 by 2 gr. This is the speed with which Veera must have thrown the apple. And now I want to find out that at what speed does it reach Soorya. I will keep that speed as Vs. So simply, again, V square minus 2 times the displacement is 2r, so 2gr. That gives us Vs square. And solving this gives you gr upon 2. Now here's the thing. We put 2 sine alpha equals to 1, right? And sine alpha came out to be 1 upon 2, which means that alpha equals to 30. But you see, guys, that we have solved this problem from Veera's point of view, and we have thrown the apple to Soorya. And it seems that Soorya must have thrown this with a speed of square root of gr upon 2, correct? Correct? But as it passes through the point of tangency, the tangent point, it goes at an angle of sine alpha equals to 1 upon 2. Our problem has still not explained that the angle with which the Soorya has thrown from the top is what? It has still not explained that. So this is where I will leave you. I will leave you to find the angle with which Soorya must have thrown the apple from the top so that it reaches in such a way. So guys, I hope you enjoyed the solution, and I will tell you the answer to the angle problem in the next video. Until then, get physics rich.